Welcome to another short video. This is to answer questions I've had over the months on logic analyzers, what type to use and how to use, and also a little bit on code reading. So we're going to use the PS4 Slim that we used from the last video. We'll go across and have a look, and you'll see there's quite a bunch of leads coming out of nowhere here. We do know white lead is the TX pin for the UART, and that's the RX pin as well, but you don't need that just for doing the boot log, which is what you do with the UART and what we're using with it. Don't know what the other three are here, and these two over here, I've no ideas yet, but I have a feeling I know that they are probably the UART from the South Bridge, because they all seem to tie up with these test points along the bottom here, which normally have jumpers on so that you can pick them up on this header. So what I've done, I've connected all these leads to a logic analyzer. There's the setup. Now, logic analyzers come in all sorts of packages, from thousands of pounds down to peanuts. This one's quite expensive, but this one isn't. Now that comes with, it's from I think it's Hobby Components. I think it was only a few quid, I can't remember exactly, I'll try and find out. Software for it you can download free, it's called SIGROC, and what I should be doing is running this to show you this, and then running this to show you this. So it's basically a gain, like with the program, there's two ends of the spectrum. So, right, well, we know the UART pin, that's the one that will read the boot log. I will show you that later. To read the boot log, if you remember, you have to set the UART flag in the NOR. So when if you follow the last video and read the NOR, you need to set the flag so that it enables the UART. I'll touch on that slightly. It is in a lot of my videos, so if you go back and have a look, you'll see. I don't really want to go over that again. Okay, so there's all the cables. These are all connected to this analyzer here. There's 8 channels. What I have got, I've got 2 that go through the UART, then through the reader, because it enables me then to send data out as well. Then the others are just basically captures. So we'll go over to the screen and we'll go a few things. Right, so we've got the UART, we've got the capture device. It's handy to have both. I'll show you why, because you need to poke the bear to get a response, if you follow me, and that's exactly what we're going to do. So what we're going to do first of all, bring up logic. So I've set up 7 channels, and we've got a terminal also to display here, and each one of these I've set to read ASCII, not hexadecimal. You want ASCII to see if there's any text, which you can also do with the cheap machine as well. So what we can do is just start this running, and I'm just going to switch the PS4 on. That is all, nothing else. So what we'll do, I'll start that running for you if you keep an eye on it. Right, I saw a bleep, and you can see down on the bottom right, and then we get the OK. So that means one of these pins has actually found the South Bridge. OK00003A, as you can see there, is from the South Bridge. So all we need to do is just roll this all back a bit and have a look and see where it was. Okay. As you can see, we got pretty much a reset on every single line. We've got a response on them too. Let's go and have a look and see what we got. Framing errors, okay, that's fair comment. That'd be from the beginning, and then somewhere down here. Let's have a look. We should have that switch on here, so it synchronises the whole machine. Down here it looks like we've got the what I'm looking for, and there it is there. So we know that comes from the TX of the south bridge. So there's the TX. When you power it on every time, if the south bridge is working, that will come up. It's always a good test of the south bridge. In the early days, that's all we had for the PS5, I might add. So we know channel 1 is the TX. So what we need to do now is start poking away at these other lines to see if we can find which one's the RX. Sort of edge the bets a little bit. Normally, and past experience, a lot of these connections and pins follow a pattern. And if we say that the TX pin was channel 0, wasn't it? Channel 0 on here is black. It actually does go through the UART. So that would be grey. So yeah, the bottom lead there, which coincidentally, so that there is the TX on the south bridge. This one here we know is TX on the UART. My guesses are that there will be the RX on the south bridge. So what I've done is connected that to the UART TX and to the logic. So what we can see is if the data's all and everything's as it should be, when I send the signal from the UART to the board, the logic analyzer will show you what I've sent and also capture what comes back if all is working. Right, now with the PS4 error data, or the data error on the south bridge, I find a lot of there's quite a few tools that don't seem to want to play ball with it. The freebie tool from PWE does, but it's all wrong because it's for a PS5. TriWe tool, that doesn't work at all for some reason. And the only one I could find that gave me any real response, well, I discovered a little Wii program just called JBrute exe, which is a very small terminal program, so you have to run it in a command mode, and it will brute force data through to the port, and you can create scripts as well, which is pretty great. So anyway, we set this all up, and what we're going to do is fire a couple of commands and see what we get. Right, okay, at error log 1, and we get a response. FFFF is typical of no error. There are 10 positions you can read, so that would be 1 to A in hex. This board hasn't got any faults, unfortunately. But what I will do is create, I'll create a crash. I'll shut the thing down when it's booted, and we'll have another look and see what we get. But for the moment, with this particular little bit of software, the other trick it will do is you can compile a list of commands that you want to send to the south bridge, and basically use this bit of software to send them. And what it does, it logs the answers, and it'll also tell you whether they're viable. So if the actual whatever you sent was totally nonsense or useless, it will tell you. So that's what this is now. You can see running JBrute com3 command list, and what that's doing now, that's hammering all the data that's in the command list to the south bridge, and what comes back is being captured in a file called results. And also, which I meant to do, was run the actual logic Analyser to show you. There's the result folder. So what we sent to it has, you see they're all FFF and yeah, A5 at the end. They're all non-error, they're all no error. So that was the command list we sent. So this is a free bit of software as well. So I'll make sure there's links to everything on the channel. Alright, now what I want to do is also boot up the PS4 and capture the UART data, which is the boot log, on the Analyser. Although, to be fair, it's just as easy to use, once you've found the pins, it's just as easy just to use the UART. So as you can see, we're going through the numbers manually. So 1, 2, 3, 4, oh, we're going up to F, which is hexadecimal, which is technically 15 or 16, depending if you start at 0 or 1. So I think it's about covered all of that at the moment with this bit of software. As I say, the only issue at the moment, all we're getting is the code errors back, not what they mean. Now, at the moment, the PS5 database is being built. I think there must be a PS4 database out there somewhere, but as yet I haven't come across it. So it's a case of, if you run the code error on a faulty machine, if you get nothing, the chances are the Southbridge is not even running. So you've got to make sure that, you know, you've got your power rails and everything. And if you run the code error and it gives you a code other than FFF, then look at the fault you're getting and you can tie the error code to that fault. Now next time, you know what that error code means. This is how we've got to build the database up. Pretty much the same way as they do in the PS5. Right, we're back on the Analyser. Now, I think this is probably a good point to try this booting everything. But what I want to do is try and capture a command list for you. It's a bit of a problem. There's just so much stuff on the screen here, trying to get everything so you can see something. Okay. Right, we'll start the Analyser. Right, there we go. That's the command list running. So what you see in the bottom right hand corner is what you'd see on a normal UART. What you saw flashing is the actual data stream that the Analyser's catching. Now this Analyser will do it, and so will the cheap one. It's just the cheaper one doesn't display it quite as nicely. So if we now spread this out, what we can do is look for each line of information. Now at the beginning, I think it was error 0, wasn't it? So that should be the first one, or I may have put version maybe at the top. I can't quite read what I put on there, or what I did now. Let's have a look. Yeah, it was error 0. There you go. So we sent the signal, and there's the answer. Let me just move that across a bit. You see there's quite a few there that were no good or errors. That just basically means that the UART doesn't recognise the command we sent at it. There's vision, or version, vision, I'm getting vision on the brain. And what you can do is open them out, and to the point you can actually read them. So there's the command, and on top of it is the repeat of the command, which pings back. And then after that is the actual, the data reply. So that would be normally an OK followed by the zeros, then the actual information. which, as you can see, so that's basically what a logic analyzer does. It can do quite a lot more, this particular one, because it will run analog as well as digital. I'm not too sure about the little one, but what I'm going to do, I propose to do a quick run of it so you can have a look. But as I say, if you're seriously into getting into digital work, then a logic analyzer is actually a great bit of kit. We've worked out what the wiring is, and there's a little capture for you. So this is for the SAF006 board. So you got your South Bridge code read on the left, TX at the bottom, RX at the top, and then your UART on the right. And you only need the TX pin, which is at the bottom. Then the rest of these pins, well, basically, we've got no use for them at the moment, so we never know. We might find some useful on the others. Or I do know there are other bits of data there. Whether we can actually find out exactly what it is, who knows? That's for another day, I'm afraid. But anyway, we've got the answers we wanted from the analyzer. I did say that we would create an error on the Slim so that we could see the error code that it generated. So what we'll do, we'll boot the Slim up and we'll just shut it off midway. The error codes we're getting from the PS4s are totally different, or most of them are totally different to the PS5, which is a shame, because if they were the same, we've already got software out there to decode the error numbers into factual data. I think some of the errors, they do look very similar. I know for a fact the error log, all F's is no error, and it looks like the crash from no power log looks very much the same. But this is something we're going to have to do over time, is to build up a database for the PS4 until we can know. I'm 99% sure most of the 4 and 5 are different. As I say, because I've got both and I've run the software on both, and the error codes are totally different. So it is a new ball game, PS4. Whether it's useful, I don't know. I think it probably is, because there's an awful lot of them out there, and they do become sort of the first go-to for people that's starting on this type of work. And if there's any aids that could be put together to help anything, like it has for the 5, then it's all good. So as you can see, okay, there's our first error code. We crashed the 4. And what we've got there now is D9, so that's an 800, 80000000004, which is error code 0, which is normally at the top of the pile. The chances are it could have generated a few others, but yeah, so you get the idea. Now that, as I say, if that came up on a working machine when you checked it, you would have known that the plug was pulled out on it midway. It may have corrupted the hard drive even. So, you know, it's always a good idea to log all these details, as I say, until we can work out exactly what they are. But that was the code, the last one that was filed, that position 0, for hoisting the plug out. Okay, well, as I say, I hope this is a bit of help, and I hope it has come across reasonably easy. The idea of this is to make it for people that are just starting on this side of the work. I'm trying not to get too busy with it, and on the other hand, I don't want to be too silly. If you know what I mean, it's difficult. But either way, I'm pretty certain that here we go. So we actually have 3 error codes there. I'll tell you, one looks familiar, and 2 does. They look very similar to same codes up with PS5 for crashing. Could be wrong, but okay, well, this is all work we're going to do. Anyway, let's move on with this video, otherwise it'll be all day. Okay, so what we're going to do now is I'm going to get Logic all connected up and set to go, and we're going to boot the PS4, and what we'll do, we'll watch the Logic Analyser as it captures all the data from both UARTs, and we can also pop across and have a look and see where the screen is, and yeah, let's see where we go. Right, well, we started the PS4. I forgot to switch over to capture, I do apologise. Right, we can see on the bottom right hand corner, that's the actual text that's being captured from the boot log, and what you see flickering up in the centre is actually the information. And at the same time, I've got the BWE software. Now we can use, this is free by the way, it's the UART reader, it's on his website and it is a free download. So now we know where all the pins are. I've just connected the UART straight to the reader, and I just put it through a restart cycle so you can just see. So we found the pins with the logic analyzers, and as I say, this is just proof of concept that it is the right pins. So that's the, although we do know that that was actually the UART log pin, but that was the only one we had made. The other ones we've found today ourselves, although there probably is some out there. Right, well, we'll shut this baby down and let's see where we go from there. Okay, so I've got the little baby reader hooked up. If I can just get it into view because the lead's not long enough, I'm afraid. I suppose if the camera go up a bit. There we go. As I say, it's from Hobby Components, and it is pretty basic. It's not great to try and capture the boot log. I don't think it's quick enough for that, but certainly for the error codes, it will show you those. Although, as I say, the UART is far better, but if you're sort of just looking to find something to look at data, don't forget these will only handle probably up to maximum of, I think mine's only 3.3 volt, so you've got to be careful. So what we've got 2 pins going to the UART and 2 pins to the boot log UART, and the other 2 going to the south bridge. So what we'll do, we'll go and see if we can find the south bridge one. So we're going to go over to the what have we got? Let's have a look. Right, there's our little program for sending the files. Now the only thing is, I'm running this other program on a totally different machine, and I'm using NDI to share the screen. It may fall over, but what I do, I'll try to show you the screen of the cheap one that I have captured, and we'll see what happens. There it is there. Now you can see it, but it's not as easy to see. I sent version. If you look, we go right back to the beginning of the frame. There it is. There's the sending frame before the transmit, sorry, before the receive frame. And I sent version, there you go. We don't really need, you could turn off the bits here. So we could turn them off, show this row, no. That's the RX row, and you could turn off that one as well. We only need 2. Okay, we don't need, there we go. So you've got, let me shrink it down a bit then. Your version, send, there's your acknowledgement above it, and there's the answer there. The only thing is it doesn't show it as, like the other one does, as a complete file. I suppose you could play around with it. I'm pretty certain there is a way of, I think you can save it as a bin file and do things like this, but if I shrink it a bit and bring it out, you'll read it. Okay, there's the triple O's, E1E, 0003, 0014, as it was before. What I'll try and do now, I'll set it into run, and from the other PC I'm going to send error log 1, 2, hang on, 0, 1, 2, 3, 4, 5, 6, 5 again. Oh dear, talk about finger trouble. 6, 7, 8, 9. That was 7. Let's try again. 9 and A for 10 because it's hex. Don't forget A. Right, and we'll go back and we'll stop that. Okay, I know you couldn't see the one I was using to send, but the more important screen is this one for you to see. As I say, this is running a little very small hobbyist unit. And there we go. Error log, there's the answer. Okay, loads of FFFs because we've got no fault. Right, just looked on the net. I found one in the UK for this particular one, and it was only a tenner. So the software is free from SIGROC. I'll put all the links up for you. So yeah, as I say, so a logic analyzer can be anything from thousands of pounds down to a tenner. But as I say, to find out what you've got to have a rough idea what you're looking for. I mean, that's obviously the case. And we just basically used it to find which was what in the way of which UARTs were what. In fact, whichever were the UARTs. Or I should say not UART, because it's actually serial pins on the board. And as I say, this would show that, the little one here would have showed you the answer for a tenner. I won't tell you how much they are because they're silly money, about £2 grand. But again, there's a lot more to this. But all you need is what this little box will give you. So as we've over the last couple of days, we've looked at CH341 for matching tenner. We've looked at this little tiny box for a tenner. All the software for both of them, like the SIGROC for this is free, and so is it for the CH341. BWE has a free version of the UART reader, which you can download. And what I used to prod the bearers to say for the code reader was another free bit of stuff, bit of software, which I'll put links in the board to. But as I say, this again is just answering a lot of questions I've had. This probably won't be a lot of interest for a lot of people. I do apologise. But I hope this answers a lot of the questions that you guys have been asking. So till next time, I'll catch up again. I have got a PS5 Slim sat here. It's been here for nearly a month or so to take apart and show the innards of. So that may be the next video, a bit of a quick one to have a look at that. What I want to do is dump the gnaw out a bit and have a look at the error codes and things like that. So that will be the next job possibly, and I'll see you soon. Thank you.